Let us now study about Ohm's law. Okay, this thing you have learnt in the 10th also. Okay, the same thing we'll just recall that. Okay, so Ohm's law gives a relationship between voltage and current. Okay, so they say according to Ohm's law, the voltage is directly proportional to the current. Okay, that means as the voltage increases, the current also will increase, provided temperature remains constant. Okay, that's the condition here. So this you learnt in lower class, that is V is equal to IR, that relation we got. But in 12th we learn how to get it in a different format using the microscopic model of current. Okay, so we in the microscopic model of current we got the equation J is equal to sigma E. Okay, so using that equation we'll find the this one Ohm's law. Okay, microscopic model of current, and then we'll find the Ohm's law. So for that first let's take conductor here. So click piece of wire, it's like a cylinder only. Okay. This thing will connect to a battery or cell. This is the positive end and this will be the negative end. Like this way. So this is positive and this is negative end. Okay. So I'll mark on top also because positive now. This side is negative. So electric field we know it starts from the positive and goes towards the negative. So this is the direction of the electric field. Okay, positive to negative. Okay. Let us take the length of the conductor to be L. Okay, it is L meters. Length is L. Okay. Then if you see, this conductor will have an area. Okay, that area is A. Okay, because I said not same chalk. Okay, this is like a circle. Okay, so it has area A. Then we see the current flows in this direction here. This is the direction of the current. Okay, so current and area are perpendicular. We can use the current density formula. Okay, then we see that there is a relation between voltage and electric field. Okay, see we say there is a constant voltage here across ends. Okay, and then we get the relation here V is equal to E into L. Okay, so from this equation what is E equal to? Okay, so E is equal to V by L. We just bring this L down. Okay, V is equal to E by L. Then now let's use this current density formula. Okay, we'll draw a line here. Current density formula, that is J is equal to sigma into E. Okay, substitute the value of E now. Substitute value of E. In substitute the value of E, what we get is J is equal to sigma into V by L. Okay, this is the formula we get now. But one more thing we know, the current density J is equal to I by A also we learned. Okay, so but current density J is equal to I by A. Okay, compare the two equations. Okay, so this one, okay, let me write this as equation 1. Okay, this is equation 2. Okay, and this is equation 3, and this is equation 4. Okay, you compare left hand sides of equation 3 and 4. Left hand side is J. Okay, so left hand side is equal means right hand side also must be equal. So what happens is, so comparing equations 3 and 4. When you compare equations 3 and 4, okay, what happens is we get thing I by A is equal to sigma into V by L. Okay, L I wrote B. Okay, now we must find what is V now. Okay, so what you do is cross multiply L upwards here and bring this sigma down here. Okay, so let's see what we get here. Take chalk here. So when cross multiply, I goes up now, I is there and L goes up. So I into L by A is down, and then we also have sigma here. Okay, bring the sigma down is equal to V. Okay, rearrange, what we get is V is equal to I into, I'll write L, I separately, into L by A into sigma. Okay, right now. So this term, okay, L divided by A into sigma, this term we call it as a resistance. Resistance. Okay. So exactly what is the resistance? I will write first. Okay, we'll write the formula, then we'll see what is the resistance. Okay, so V is equal to I and resistance has a symbol R. Okay, this thing you are familiar with. V is equal to IR is a it's a statement of Ohm's law. Okay, V is equal to IR. In this thing, V means the potential difference or voltage, you can say common terms. Then I means the current, R is the resistance. Okay, so this is what we know. But now let's see what's meant by exactly resistance. Okay, see, let's take a river here. Okay, in a river there will be rocks there. Okay, when water flows, the rocks will slow the water. Okay, we say the rocks resist the water. If there are more rocks, means the water flows slowly. Same way in an electric wire. Okay, you have, let's imagine this is an electric wire here. There are atoms there. Okay, there are atoms here, and we also first we saw that when electron goes, it will hit the atoms also. So atoms will create a resistance to slow the electrons. Okay, so that's the cause of resistance in the wire. Okay, then you can see one more thing. If the length is increased, if there's more length, means there will be more resistance. Okay, that's one thing to note. Then let me take chalk here. Okay, now from this formula, what's R equal to? R is equal to V by I. Okay, just bring I down here. Okay, so V by I is equal to R. So this is called as resistance. R means resistance. Let's see what is the S unit here of resistance. Okay, S unit is ohm, OHM. Symbol is this one, omega. Okay, this also you learned in lower class. So the same thing on Ohm's law you learned in lower class, we have now derived in different format using the microscopic model of current. Okay, so let me rub out the first equation for another concept. Okay, the same thing only, but another concept in Ohm's law. So I said, always know that V is like IR. That means as the voltage increase, current also will increase. Okay, that is true for some conductors. Okay, we say ohmic conductors, we say like this way. Let me take V here on the x-axis and I on the y-axis. Okay, this is the x-axis and this is the y-axis. When you plot for some conductors, okay, voltage is directly proportional to the current. That means as voltage increase, current also will increase, and the graph will be like a straight line through the origin. Okay, you find the slope of this like this way. Okay, the slope of this, that means this one, delta I by delta V, will give us 1 by R. Okay, so this is true for some conductors. They obey the Ohm's law. Okay, so we call them as ohmic conductors. So what's meant by ohmic conductors? They obey the Ohm's law. Okay, as voltage increase, current also will increase. But there are some conductors or some special devices. Okay, they do not obey the Ohm's law. As the current increases, voltage will not increase. Okay, or as voltage and current also will not increase equally. Okay, let's see about them, how the graph will be there for them. Okay, so V and I, if you see the graph here, it will be like curve only. Okay, it's not a straight line. Okay, this we say non-ohmic conductors. Non-ohmic conductors. Okay. Is any example there for it? Yes, that's an example. Right here, example, diodes. We're going to learn about diode. Okay. A diode is a very important thing we use in electronics there. They will not obey the Ohm's law. Okay, if you see the graph for them, they will curve like this way. Okay, so this is about Ohm's law. Okay. We saw how to get from microscopic model also, and then we studied about ohmic and non-ohmic conductors. Okay, so thank you for watching.